Video I'll be showing the test for lead ions. As you know, lead is in group 1, so first I'll be showing you the test for group 1 and then I will be proceeding with the test for lead ions. So this is my salt, this is lead nitrate. Okay, you can observe that the salt is colorless and crystalline in nature. So I will take some of this salt in a test tube. As you know, first we check for group 0. Only if group 0, which is ammonium ion, is absent, then only we will perform the test for group 1. So since I know that lead is present, so I am not wasting time in showing you the negative test for group 0, because I have already made the video on test for ammonium ions. So I will directly proceed with the making the original solution. So I'm adding some distilled water over here because lead nitrate is soluble in distilled water. So I have to dissolve it completely. If you see that some solid is left which is not dissolved, you can filter this solution and you can use the filtrate for original solution. I think the white colored precipitate which I can see is due to the hydrolysis of lead nitrate. So I'll be adding a bit of dilute nitric acid into it. Generally, I don't suggest making original solution in nitric acid because then it oxidizes the hydrogen sulfide gas into sulfur. But here, since I am showing you the precipitation of group 1, therefore I have used over here nitric acid just to dissolve this lead nitrate completely. Anyways, it is not clearing up, so I will just going to filter it. So I will be filtering it through some cotton. When our original solution is prepared, then I'll be adding dilute hydrochloric acid into it, which is the group reagent for group 1. Observe when I add dilute hydrochloric acid into it. On adding dilute hydrochloric acid, a white crystalline precipitate. Observe. On adding dilute hydrochloric acid, a white crystalline precipitate of lead chloride is formed. You can observe that the precipitate is crystalline. Now, at this point, you don't have to stop adding dilute hydrochloric acid. You have to add hydrochloric acid until all the precipitation is over. So I'll be stirring this with my glass rod. So a white precipitate indicates the presence of group 1. What are the cations of group 1? It is lead 2 plus, silver plus and mercury plus. Now just by this test we cannot tell that lead is present. We can tell that okay, group 1 is present. Now it can be silver also, lead also and mercury also. Now how will we separate lead ions from silver? So lead chloride is soluble in hot water, whereas silver chloride and mercury chloride are not soluble in hot water. So we will dissolve this. First of all, we will filter this solution and preserve the filtrate for analysis of group 2 and further groups. But since over here I am using only one cation, I will be not filtering this precipitate. I will be boiling the precipitate in same solution. But if you are given a mixture of cations, then you have to do this. So you can see that the volume has already become very large. So I'll be transferring all these contents into a boiling tube. So you can see that I have decanted off some precipitate, and to this I'll be adding some distilled water and boil it. Now you observe that on boiling the precipitate disappears. If on boiling the precipitate remains, that means lead chloride and mercury chloride may be present. So for that we would filter this solution, and then with the filtrate we would test for lead ions. So we would transfer the filtrate into 4 parts. So since I am working with a very less amount of solution, you can see that in one solution, when I poured down the solution cooled down, and on cooling again the white precipitate of lead chloride has appeared. Unfortunately my bigger boiling tube broke, so now I'll be showing you the test with this one. So I have combined both the parts again, and now before proceeding with dividing the parts, in the first test tube I'll be taking potassium iodide solution. You can see this is yellow color. This is the presence of lead iodide. Let me wash these test tubes first. To the third test tube I'll be adding some dilute sulfuric acid. To the fourth test tube I'll be adding some potassium to the second test tube I'll be adding some potassium chromate solution. I'll be heating this to dissolve this precipitate. Once our precipitate is dissolved, then I'll be adding this solution into each of these test tubes. First I'll be adding to potassium iodide solution, and you can see the observation of a golden yellow color. When I added to it is actually a golden yellow precipitate of lead iodide. Now I'll be adding this into potassium chromate solution. You can see the observation of a yellow color precipitate, but in this case the yellow color is different. Now I'll be adding this into sulfuric acid solution or dilute sulfuric acid, and you can see the observation of a white precipitate of lead sulfate. Now as I have already shown that on cooling the lead chloride separates out as white crystals. Now I'll be adding potassium dichromate to the leftover this solution, and even on adding potassium dichromate solution, a yellow precipitate of lead chromate is formed. Now this precipitated lead iodide is also soluble in hot water, so I'll be heating it to dissolve all the precipitate formed. In this case some more water also has to be added. Lead iodide will dissolve in hot water, and when it is cooled it will separate out as golden rain.